The reason that I'm making this video is because I want to bring it out into the open, something that's kind of unspoken in physical science classes. Let me give you a little history. Back in 1974, when I took an introductory physical science class in 9th grade, IPS for short, this class was pretty heavy on algebra, where you had to cross, multiply, and divide, to find an answer. This is when, in my history, I was able to finally learn algebra. Had it not been for this class, and me struggling through it, getting a tutor, almost failing, I wouldn't be where I am now. So it took a class like this that had concrete examples where I could learn the math for me to be able to advance mathematically. And I believe that we should do the same to our 6th grade students. I've heard a lot of people say, the kids can't do the math. And to me that means that I'm going to short the math a little bit. I'm just going to show them the concept, we're going to do a lab on it, but we're not going to do any math with it. I believe this is the perfect time to actually do it, to teach the math to these kids. I believe it's going to help them in the future, just like it did in my history.
I think that anytime kids are able to do a concept in both math and science, then that gives them a really clear connection between what something looks like in different situations. So they're better able to understand and be able to extend their learning. I think, for example, a lot of times we talk about independent and dependent variables when we're talking about X and Y and what that looks like with a graph.
I do,
yeah, and so, but it's really great for us in math because you've done so much work with independent and dependent variables that on our end we get to just build on what they've done there. And so that makes our lives so much easier and makes, for really great learning for kids.
Well, thanks for bringing up a cross-curricular example. So, what else? Anything else?
Ideally, if everything were perfect, you would cooperate with each other, the science teacher and the math teacher, and you would find, as a math teacher, you would find out what math concepts science needs as the year goes on, or the progression. Or vice versa. The science teacher will find out what the math progression is, and then you would co-teach at the same time that same concept. So, like, when I'm doing positive and negative numbers with my 7th graders, I actually use the example of neutrons and protons and electrons. Or electrons, protons are positive, electrons are negative, and together they cancel each other out. And so if you have 20 protons and 7 electrons, what do you end up with, a positive charge or a negative charge? As an example. And how did you figure that out? Because of canceling terms. And so, but that's brought up in a different way. When you were doing like the graphing, right now we're doing independent, dependent variables for graphing linear relationships, and if you were teaching at the same time, they would go hand in hand, ideally. But if it doesn't happen at the same time, I don't have a problem with it being introduced or taught in the science classes, because usually when it is taught, it's actually nice because the kids are like, I remember that Mr. Crowder showed me, or so whoever my science teacher showed us this and we talked about this. And then we can just reinforce or extend the learning into more depth, which is what we want. And that's what we do. Where you guys, I could be wrong with this, but you show them kind of the bits and pieces of it so that they can perform their lab experiments. And then we take it a little bit further and we look at the pattern relationships, we look at equation relationships and the connections between the two.
Science allows for a really great application of skills they're learning in math, like a hands-on experience.
It takes what we do. We teach the how-to part where you teach the why and the where you would apply it.
And I know Philippe took a class this summer. You're telling me about this physical science class, and then you were thinking of incorporating some of that, or maybe in your classroom.
My 2 cents on this is that, like, physics, specifically physics, but also all science and math are so closely related, and like you said, it's kind of, one's an application and one's kind of more numbers, pure based. And so for me, combining them or teaching them simultaneously is a really good way for some students who really like science to see the value in being successful in math, and for some students who just like math and maybe don't like science as much to see the value in science. And so it's kind of it's like two ways of engaging students.
Yes.
And killing two birds with one stone, but you're getting to see two sides of the same thing.
And ultimately, that's why I'm bringing this up. Any caveats that you guys want to bring up, like we might mess up somehow? Like, is there any problem?
I think one thing
Potential problem.
that we try and work really hard on is for kids to understand why they do something. So we tend to wait to teach formulas before kids have had a lot of experience with something.
Right.
And so I think that we would just want it to make sure that kids understand why they're doing what they're doing rather than just applying a formula to something.
Right. Don't just throw a formula out there with like, this means this and this is why it's there. Right.
I agree with that. In a lot of science classes that I've taken, we've gotten the formula, and then the math is like, you do this step, this step, this step. And being a math person, I was able to understand why, but a lot of people just say, I do this step, I do this step, I do this step, and I get the answer.
Right.
So it's a little more than that. But that's also where the combination comes across, and that could be part of the math teacher's responsibility or part of the science teacher's responsibility.
In reasonability for your answers. A lot of kids, when they get a formula, they just plug it in, but they don't really understand what their answer means, or is their answer even reasonable, especially if you're in most real life applications when you do your science experiments. You don't have pretty numbers. And because you don't have pretty numbers, you allow the kids to use calculators, which is fine.
Right.
But do they understand what they're really typing in, and the result of that process, is their answer even reasonable? So before, and that goes to what Bethany was talking about, which is having them think about what are they putting in and what's a reasonable result that should come out of it.
Right.
So when they type it into their calculator and they get an answer that isn't reasonable, they can actually see it and go, whoa, something is wrong. Red flag should pop up and tell them. So a lot of it is reasoning skills is a good thing that I think is a good application, especially in the science fields, where you can actually ask them, to approximate their answer before they actually do it.
Right, and a caveat. If you're just handing out a
if you
calculator,
just say do this and the calculator,
and not really teaching them how to use it or explaining why you do this first and this second,
instead of just saying,
that can cause a problem.
Here's the formula, just plug in these numbers here.
Right, thank you.
But they have no clue why.
Yeah.
And checking your answer too, as
And
part of that.
yeah.
You can always go back and plug it back in.
Is there much math in the 7th grade?
Not
science
too
class?
much. Not as much as there was last year.
Yeah. So in 6th grade, like on a scale of 0 to 10, where would you say the amount of math is?
In 6th grade,
Yeah.
I'd say about a 6.
And then for 7th grade, where would you put it?
About a 3 or 4.
Okay, all right. So less, but there's still some.
Yeah.
Class.
Probably around 2, maybe.
Okay, not a whole lot.
No.
And then how does that compare to, let's say, 6th and 7th grade?
It's a lot less, actually. We had a lot more in 6th and 7th grade.
So more in biology than in 8th grade too?
Mm-hmm.
Okay.
Probably about 7.
Like around 6 and 7.
How do you feel about that?
Well, I'm not the best at math, but it's definitely like what I learned in math, which is actually right before this, I can kind of incorporate to what we're doing here, and then what we're doing in here can help me with what we're doing in math, so I'm fine with it.
6 or 7. Let's see, 7-ish.
A little above like just a medium amount. Where do you think that is on the scale?
Like 1 or 2.
Okay.
Around 0.
Whoa, okay, not very much.
Yeah.
And then what about the year before that? You had me the year before that.
Yeah.
So in physical science.
6, probably.
Yeah, okay, so a little bit higher.
4 or 5.
Okay, so kind of even.
Yeah.
And then how do you feel like it was the year before that in 6th grade science?
Probably a 7. That was a lot of math.
Yeah, a little more, yeah.
Yeah.
Did it help you in your math class at all? Like after 6th grade science, and then like what you're doing in math now, let's say?
In math, well, yeah, I guess with like the metric system, it helped me in math.
Using formulas, learning them. What do you think you're getting out of it?
Like, so you basically know how like the world works.
What do you think about doing all the math that we're doing in class?
It's fun.
You actually like it?
I think it's actually really interesting what we learn because it's not just like we're learning a lot of useless stuff. We're actually learning things like about that we use in like general life. Like we just learned about refrigerators. Like like we're around refrigerators about every day. So just finding out stuff that we can like relate to.
What parts do you like the most?
Probably doing the labs.
You like the labs most?
Yeah.
So how do you feel the math is in those labs?
There's not as much math as I would have expected. There's still.
Really? Okay.
I would have expected a lot more math probably, but maybe that's just right now. But there's still quite a bit of math to like get the experiments done and do the calculations to find what we need.
Okay. And then what about the tests?
That's probably the most math.
Gives you like context kind of how you might need to use it.
And what's your favorite part?
Well, I really love all of it, but probably when you explain things and then I finally like get it.
You like the little light bulbs
Yeah.
turning on? So is that like happening on a daily basis? Like,
Yeah, pretty much.
Okay, cool. Do you feel like it's necessary to have math in here? Or do you feel like that's like, what is he thinking by
Yeah.
having math in this class?
Yeah, because I feel like science is a lot of math, just in general. Science is a lot of math.
How are you doing on the formulas?
Good.
And then we put the numbers in there?
Yeah. The only hard part is like the order of operations part,
Okay.
where you have to multiply. And also,
Gotta remember
like,
that.
yeah, and then like momentum is MV or whatever the formula is. I'm having trouble remembering what the formula is for what thing.
For what it applies to.
Mhm.
Yeah, okay. So do you feel like you'll get better at that later, like when you do more of that in high school?
Yeah.
Yeah,
And
probably.
I'm already getting better at it, so.
What do you think's the hardest part of the science class?
Probably having to remember like all of like F equals MA and things like that.
The formulas?
And then also the units, but like joules.
Right. And then do you feel like that's going to help you in the future? Like you're going to be using that?
Most likely, yeah.
Do you feel like it's helping you in math at all?
Yeah, like right now in math, we're actually doing the meters per second.
Oh, cool. Speed. And what are you guys learning about right now?
Right now we're learning about the solar system.
Okay. Do you feel like there's going to be some math in that?
There should be, but I don't
You would
know.
think, right?
Yeah.
Do you feel like any of that is going to help you in the future? And if so, like what parts do you think are going to really help you?
Well, the learning how to balance equations can be helpful in engineering, or if I go into chemistry,
Yeah?
that would be really helpful.
Okay, all right. And then, do you remember any formulas?
No.
Like F equals MA or anything?
Oh, I do
Yeah,
remember
yeah.
that. Yeah, force equals mass times acceleration.
All right, awesome. I like to start the year with the basics, like how to write a proper conclusion, basic lab expectations, and graphing. So the first lab should be simple. So really not a wet lab with a bunch of cleanup, but still have a useful concept that might be useful later on. I got this one straight out of a book a decade ago, The Shadow Lab. The kids measure where a shadow hits based on how far a lamp is held out. They learn independent and dependent variables, something about light, shadows, graphing, and exponential curves. This lab has it all, and all you need are meter sticks and lamps. One of the most critical mathematic relationships is the inverse relationship. My mantra is that when you have a fraction, always divide the bottom into the top. So the first set of demonstrations and labs I give that include the inverse relationship is finding a speed from distance and time. A rolling trundle wheel is a great tool that helps to get kids engaged. They learn to divide distance by time to get the speed. Other inverse relationships that we might touch on are Pascal's law and the ratio between the distance input and output plungers move compared to the areas of their surfaces. And every science teacher's favorite, density. If the volume is greater, the density is less. Two examples I like to use are A sponge is made from a dense piece of plastic that will sink if you drop it into water. But when they blow it out and expand its size into a proper sponge, it floats, so its density is less than 1. And if Superman were to smash all the steel together that makes up a ship, it would sink. The reason that it floats is that all of that steel is spread out into a large volume. So having done the exponential shadow lab graph, the next progression after speed is acceleration. Here they're learning exponents and derivatives, something that I struggled to teach until I met Robert Croft. He opened my eyes to this great lab that I call the Free Fall Acceleration Lab. The kids really gain a clear understanding that everything falls at a changing rate. I like to tell the kids that they're learning calculus. Speed is the first derivative of distance, and acceleration is the second derivative. Next comes Newton's laws of motion and forces. Students learn to manipulate formulas and use algebra to solve equations. For many, this is their first exposure to algebra word problems. With laws of motion, we do a lab I call Feel the Power Lab. The kids run stairs and compare their amount of work and power. Later in the year, we do another lab called We All Scream for Ice Cream. In the ice cream lab, they learn that it takes more energy to freeze a small amount of cream than it takes to run those stairs in the power lab. We end up with a scatter plot graph from all the teams in each class, usually the first time our kids have ever seen one, and so critical since they're common in higher levels of science. Special thanks to Lucas Carmalt for simplifying the ice cream lab procedure by using water's heat of fusion, and we only measure the ice before and after the ice cream gets made. There's a great historical progression with Newton, Du Châtelet, Leibniz, and Young for the derivation of the kinetic energy formula. Through an internet search, I found a method for measuring the volume of a crater produced by dropping an object into clay by counting drops. So thanks to a University of Illinois physics professor, we now do a kinetic energy lab. I always like to end our study on kinetic energy with E equals mc squared, and how Einstein's famous formula comes directly from the kinetic energy formula. Speed, acceleration, forces, energy, a natural sequence that springboards into temperature and then states of matter, and finally matter itself, ending the year in chemistry.
Look, you even got an expo.
Yeah, no, that's my
endorsed by Expo.
Yeah.
Here we go.
Isn't that like the ultimate teaching sponsorship? Is if you get endorsed by Expo?
Who is teaching, I want to be afraid.